It's the middle of the day somewhere in the Northern Territory. Hundreds of tiny black ants are streaming out of the dirt with one thing on their minds. And crawling out of the water to meet them is something that has been terrorizing this continent for almost 90 years, a baby cane toad, barely the size of your thumbnail. The toad does what its instincts tell it to do. It sits completely still. It figures its poison will protect it. Crocodiles have dropped dead from eating its relatives. Dingoes, goannas, snakes, all of them leveled by the same chemical weapon baked into this animal's skin. But these ants don't have hearts. And the toad's poison only stops hearts. Within seconds, dozens of ants are swarming over the toad's body, tearing through its soft skin with their jaws. By the end of the afternoon, that one ant colony will have taken down more baby toads than any government trapping program caught in a week. This was the moment researchers had been waiting for. But the story of how the cane toad took over an entire continent in the first place, and why it took nearly 90 years to figure this out, is a lot more complicated than it looks. The mistake that ate Australia. To understand how the meat ant became a secret weapon, you first have to understand just how badly everything went wrong before that. Back in 1935, a group of agricultural scientists made one of the most consequential bad decisions in the history of conservation. Queensland's sugarcane industry was getting destroyed by two species of beetles, the French's cane beetle and the greyback cane beetle, and somebody had a big idea. They had heard that cane toads in Hawaii and Puerto Rico had been used to eat beetles in sugarcane fields. So they imported 101 cane toads from Hawaii, bred them up to around 3,000, and released them into North Queensland. The problem was discovered almost immediately. The beetles they were supposed to eat lived at the top of the sugarcane stalks. The toads lived on the ground. The toads couldn't reach the beetles, had zero interest in climbing, and by all accounts simply wandered off into the Australian bush to do whatever they pleased. What they pleased, it turned out, was breeding at a scale that is almost difficult to process. A single female can produce up to 30,000 eggs in one clutch. They breed multiple times a year. They have no natural predators in Australia. Nothing on the continent evolved alongside them, so nothing knew they were dangerous. A curious goanna would snap one up and be dead within minutes. A northern quoll, a small, cat-sized marsupial, would eat one and that would be the end of it. Even freshwater crocodiles were dropping dead along riverbanks where cane toad populations had just arrived. The numbers tell you everything. In the 1940s, the toads were spreading about 10 kilometers a year. By the 1990s, that had jumped to 40 kilometers. Today, it's more than 50 kilometers a year, and there are now over 200 million of them spread across more than 1.5 million square kilometers of Australia. They've rolled through Queensland, across the Northern Territory, and are pushing deep into Western Australia. And for decades, every solution humans tried fell embarrassingly short. But what nobody noticed was that the outback had already found its own answer, and it had been crawling right under everyone's feet the whole time. The creature that doesn't care about the poison. Here's the thing about cane toad poison. It's not just toxic, it's specifically designed to stop the hearts and nervous systems of vertebrates. Anything with a backbone. Birds, reptiles, mammals. The compound, called bufotoxin, is produced in big glands on the toad's shoulders and floods out whenever the animal feels threatened. It's so potent that just getting it in your eyes or mouth is enough to cause serious damage. For 90% of Australian predators, this makes the cane toad essentially untouchable. But the meat ant is not a vertebrate. It has no spine. It has no heart in the conventional sense. Its body runs on a completely different biological system, and the toad's poison simply has no pathway to use against it. To a meat ant, a cane toad is not a chemical weapon in disguise. It's just a slow, soft pile of protein sitting on the ground in the middle of the day. Meat ants, scientifically called Iridomyrmex purpureus, are already one of the most aggressive and widespread ant species on the continent. Their colonies can hold hundreds of thousands of workers. They are famous for one specific talent, picking a carcass completely clean in a very short amount of time. That's why they're called meat ants. They are efficient, they are coordinated, and they are absolutely everywhere across tropical and subtropical Australia. What makes them so dangerous to young toads is a combination of timing and behavior that nobody properly studied until the early 2000s. Meat ants are day-active foragers. They come out when the sun is up, when the heat is on, and when the ground is baked dry. And it is exactly during the heat of the day that baby toads, called toadlets, need to crawl out of the water and find shade before they dry out. Two animals, in the same place, at the same time. One is completely immune to the other's only defense. But what researchers found when they actually went out and watched this happen up close was far more interesting than anyone expected. And it revealed something about the toad that turned out to be its single biggest weakness: the evolutionary trap. Professor Rick Shine from the University of Sydney has spent more of his career studying cane toads than almost anyone else on Earth. His team, known informally as Team Bufo, has been pulling apart every aspect of toad biology and behavior for years. And what they found when they compared cane toad behavior to that of native Australian frogs was what Shine called an evolutionary trap. Here's what that means. Cane toads evolved their behaviors in South and Central America, where they were surrounded by predators that the poison could actually stop. So their anti-predator strategy was simple: when threatened, sit still, puff up, and let the poison do the work. In South America, that strategy worked. Any snake or lizard that bit down immediately felt the effect and backed off. So the toad never needed to be fast. It never needed to escape. It just needed to be toxic. Native Australian frogs, by contrast, evolved over millions of years with meat ants as a neighbor. They learned to be nocturnal. They stay hidden in vegetation during the day when the ants are active. And when they do get caught by an ant, they move fast. Tests showed native frogs could sprint away from an ant attack in about 1 second flat. Cane toads, on average, take about 5 seconds to react. And 5 seconds is an eternity when a recruitment signal has gone out and the whole colony is on the way. When a meat ant finds a baby toad and bites it, it releases a chemical signal. Within moments, tens to hundreds of ants arrive and pile on. The toad, following its programming, sits still and waits for the poison to save it. The poison does nothing. The ants tear through the soft, thin skin of the toadlet, which at this age hasn't even fully developed its toxin glands yet, and the result is swift and brutal. What made this discovery so significant was not just what it meant for individual toads, but what it suggested about the entire invasion. The toad's greatest strength in South America had become its greatest weakness in Australia. And researchers realized that if they could amplify that weakness, they might finally have a real tool. The question was whether they could actually make it work at scale, and what they tried next was almost embarrassingly simple. The research team set up their experiments at the edges of ponds in the Northern Territory, the kind of shallow, murky waterholes where cane toads come to breed by the thousands. They wanted to know whether they could artificially increase the number of meat ants near the water, places where ants don't naturally spend a lot of time, to catch the toadlets at the exact moment they were most vulnerable. Their method was not a $1 million piece of technology. It was canned cat food. By placing small amounts of bait near the shorelines, tuna, chicken-flavored cat food, bits of raw meat, they attracted meat ants to the water's edge in numbers 4 times higher than normal. And then they just watched what happened when the toadlets started emerging. 98% of the baby toads that came out of the water were encountered by ants within minutes. Of those, 84% were immediately attacked. Over half were dead on the spot. And of the ones that managed to get away, nearly 90% died within 24 hours anyway, either from their injuries or from the stress making it impossible for them to find shelter in time. Those numbers are extraordinary. No trap, chemical, or community effort had come anywhere close to that kind of result. And the best part, the part that made this genuinely exciting to conservation researchers, was that native frogs were completely unaffected. Because native frogs are nocturnal and know how to avoid ant colonies, not a single study showed meaningful harm to native frog populations from the amplified ant presence. The intervention was almost surgically precise. It targeted one species and left everything else alone. It costs almost nothing. It requires no foreign animals being introduced. No chemicals in the water. No genetic modification. No complex delivery system. Just a bit of bait, a pre-existing native predator, and the patience to let nature do what it already does. But while this was a genuine breakthrough, something else was happening with the toads themselves that made the situation a lot more complicated than a simple can of cat food could fix. Here's what started making researchers genuinely nervous as the meat ant solution was being celebrated. The cane toad, and the decades it had been spreading across Australia, had been quietly changing itself. Researchers fitted toads with tiny radio transmitters and tracked their movements across the landscape. What they found published in the journal Nature was that toads at the very front of the invasion line, the scouts, the pioneers pushing into brand new territory, had legs that were up to 45% of their total body length. Toads from older, well-established populations further back had legs closer to 40%. That might sound like a small difference, but in practice it translated to toads at the front line covering nearly double the nightly distance of their counterparts. They were faster, had more endurance, and crucially, their offspring inherited those traits even when raised in controlled lab conditions. What that means is that the cane toad is actively evolving in real time to become a better invader. The annual rate of spread has increased fivefold since the toads were first introduced. What was 10 kilometers a year in the early decades is now over 50 kilometers. And the selective pressure driving it is almost darkly elegant. The fastest toads hit new territory first, breed in areas with no competition, and pass on their longer legs to their offspring. Evolution on fast forward. There is a catch, though. Those longer legs come at a cost. Researchers found that many of the long-legged frontier toads were developing severe spinal arthritis from the physical strain of moving so far so fast. Bodies that evolved to sit around a Brazilian swamp and wait for flies were now being pushed across Australian desert at speeds they were never designed for. The toad was winning the sprint, but it was breaking itself in the process. What this evolutionary arms race means for the meat ant strategy is something researchers are still working through. Because the ants are most effective against the youngest, slowest toads. As those frontier adults get faster and harder to catch in adulthood, the pressure on the toadlet stage becomes even more critical to hit. And there are some researchers who believe that the outback itself may have more tricks up its sleeve than just the ant, because other native animals have started doing something that no one taught them to do. One of the stranger and more hopeful threads running through all the cane toad research is the evidence that native Australian wildlife is beginning to adapt to the invasion on its own, in ways that nobody predicted and nobody engineered. Several bird species, most notably some corvids and ibis, have figured out how to eat cane toads without being poisoned. They flip the toad onto its back and eat from the underside, the belly and the organs, which contain no toxin glands. The glands are only on the back and shoulders. This behavior has been documented spreading across bird populations in areas where the toads have been present for decades, suggesting that it's learned and shared, not just a lucky accident by one clever individual. Even more striking is what's happening with some snake and lizard populations. In areas where the toads have been present long enough, decades, not years, some populations of predators show a measurable shift toward smaller head sizes. Because the danger of eating a toad scales with how big a toad you can fit in your mouth, predators with naturally smaller mouths were more likely to survive the initial wave, more likely to reproduce, and over time, their traits became more common in the population. The toad invasion is reshaping the predators that survive it. These are slow processes. They don't help the animals dying right now at the leading edge of the invasion. But they hint at something important. The continent is not simply being overrun without resistance. It is pushing back. Imperfectly, gradually, expensively in lives, but it is pushing back. And the meat ant research fits into this larger picture. Scientists aren't trying to introduce something new into the ecosystem. They're trying to amplify what's already there. Taking a native predator that already kills thousands of baby toads every year and giving it a slight advantage in the right place at the right time. It's less a human solution than it is a human-assisted natural correction. Whether that correction will ever be enough to turn the tide on 200 million toads is a question that nobody can honestly answer yet. But something is changing in the Australian bush. The ants are working. The birds are adapting. The land is learning. And the toad, for the first time in 90 years, is not having things entirely its own way.